Welcome to this lecture. In this lecture, we are going to solve the following problem. Minimize z, which is equal to 3x1 plus 5x2, subject to three constraints: x1 plus x2, which is greater than or equal to 200, x1, which is less than 80, x2, which is greater than 60. Okay, in order to solve this equation, first we have to find out the feasible region satisfied by these three constraints. In order to find the feasible region, we need to uh, draw the given regions in the graph sheet. So first we would like to find out the first region covered by number line 1 solution. Let us consider the first equation be 200. Let us find the points on this line by taking, if x1 equal to 0, then 1 implies x2 becomes 200. Okay, on the other end, if x2 equal to 0, then x1 equal to 200. Therefore 0 comma 200 is a point. Also 200 comma 0 is another point on the line. Okay, which is step number 1. Okay, in second line is a line passing through 80 in the x1 axis, which is parallel to x2 axis, and the line third one is passing through the point 60 in x2 axis, which is parallel to x1 axis. Let us draw the graph. Okay, let us consider it to be equation number, sorry, x1 axis, and it is x2 axis, which is 0 comma 0. Always our motivation is finding the points in the first quadrant. That's why we are restricted onto first quadrant, which is, let us consider it to be 20, 40, 60, 80, 100, 120, 40, 60, 180, 200, 220, which is 20, 40, 60, 80, 100, 120, 40, 160, 180, 40, 60, 200, which is x2 axis. Let us first find out the region covered by the line 1, which is 200, 0, sorry, 0, 200 and 200, 0. Which is equation number 1. Actually, it is given in the greater than or equal to, right? If it is greater than or equal to, we need to consider all the region above this line. Let us consider it to be, suppose the graph is restricted. Suppose it is a graph sheet, then we need to consider the portion we may cover and the region above the line 1 by pink shaded regions. Next, let us draw the identify the region covered by this x1 less than or equal to 180. Okay, x1 less than or equal to 180. Here it is x1, which is 180, sorry, 80, 0. We need to draw the line passing through here, which is given in the less than or equal to. Therefore, we need to cover the region which is equation number 1, which is equation number 2. Okay, from the line 2, the region is like all the regions which is covered by this. Okay, I think it is not clear. I will make it to another color. May visualize this. Okay, so next number line 3, x2 greater than or equal to 60. x2 greater than or equal to 60. Here Just draw the line passing through x2 equal to 60 and parallel to x1. Hence it is greater than or equal to the, okay, we can, which is equation number 3. Yes. Okay, all the lines and the strips. Okay, let us find the feasible region containing all the three shapes. Okay, the portion, okay, not, it is not visible. Okay, I will make it another color, which is green. I think it will be visible. Okay, the region, this region covers all the three types of colors. Right? Okay. Okay, look at the picture. Okay, the feasible region is here, but it is unbounded. It is unbounded above, right? In this case, it, this type of feasible region, that is, if it is unbounded above, such type of problem may have minimum solution, not maximum solution, not maximum solution. But our motivation is finding the minimum solution, therefore it is possible only. Let us identify the possible region. So possible, let us find out the corner points of the feasible region. Okay, it will help us to find its minimum value. Here a, here is a point A, here is a point B. Okay, we don't know what is A, we don't know what is A, but we know the point B, which is 0 comma 200. Let us find the points point A, which is the intersection of line 1 and 2. Okay, solving 1 and 2, we will get the point A. Since x1 plus x2, which is equal to 200, and x1, which is equal to 80. Therefore, solving this, we get x2 equal to 200 minus 80, which is x2 equal to 120. So the point A becomes 80, 120. Let us find the minimum of the objective, minimum value of optimum solution. The points table, point step number 4. Here the point A, which is 80, 120, and the objective function, which is given by z equal to 3x1 plus 5x2. Okay, if you substitute this value, 380 plus 5 into 120, which is 240, 60, which is 840, 840. Okay, and the next point, b equal to 0, 200. Here the value of 3 into 0 plus 5 into 200, which is 1000. So what is our motivation? Is finding for what value of this problem have the minimum. Here the solution is this minimum value. Therefore the optimum solution is x1 equal to 80 and x2 equal to 120, and the value of the objective function at the point minimum of z equal to 840. That's all from this lecture. Thank you.